Okay, welcome back. This is lesson 13 of Python for data analysis. And today we're going to introduce Matplotlib, which is the primary plotting package for Python. And then we'll follow that up in the next lesson with Seaborn, which is another plotting package that's built on top of Matplotlib that provides some additional functionality. So as usual, we're going to go to the lessons folder and download the lesson for today. So we're on lesson 13 here, and we're gonna yeah, is that like there's something going on with GitHub, or is it the same on your screen too?
Yeah, I just clicked on download and it opened the RAW. I thought it was going to download it.
Okay.
The Seaborn one comes up with the RAW option.
Okay. Wonder why that is. So you can click on the download link and it'll work. So this is what we want. We want to see this this JSON format file, which is what we want to download. So we copy that link, open up a terminal. We're going to go to the our lessons folder. We're going to do curl -o and that lesson in quotes. You can also use wget if you have that on your system. And we're going to source activate Python 3. And then we can launch Jupyter Notebook. And of course, if you're using Windows or another system, maybe you're using conda activate instead of source activate, etc. Okay, so we'll click on lesson 13. So today's lesson is based on a tutorial by J.R. Johansson, and it's a really nice introduction to Matplotlib that I really liked and I wanted to use for the course. So you can find that here. You can also refer to our textbook for reading for the day, which is chapter 9 of McKinney's Python for data analysis on plotting and visualization. So you can see there's a lot in the table of contents. This is pretty finely divided, so there's not that much material, but there's a lot here. So you can use this to navigate around. In the notebook environment, what we need a way to make sure that the figures that we plot show up in the notebook. And so there's this magic command which we always use at the beginning of our notebook. Like you can do it, and I often do it in the same cell as I import packages. Here it's separate, but it's %sign matplotlib with no space there, space, and then inline. So matplotlib inline. This will make sure that the graphs from matplotlib get displayed inline in the notebook. So there's some text here. I won't read through all of it, but Matplotlib has a lot of advantages. You can it's pretty easy to use. It supports LaTeX for formatting labels. You can control. You have a lot of control over the figures. You can export in lots of high-quality formats that a scientific journal or your thesis requirements would ask for. So vector graphics, for example. There's also a graphical user interface, which we won't really work with today. So one thing to note is that if you're used to using MATLAB, if you want to get started quickly, there is a MATLAB-like emulator or interface called, or API is the language we use in computer science, which is Application Program Interface. And to use that, you can use this command from Pylab import star, which will say from Pylab I want to import all of the functions in Pylab. However, usually we're not going to use this command. We're going to use import matplotlib.pyplot as plt, and so we're going to use plt dot, plot or plt dot etc. To make our plots. And I think, okay, one thing I need to do is I need to reset the output. So I'm going to go up to kernel. I'm going to restart and clear output. And now I'm going to go to cell, and I'm going to say run all above. So this is going to get me back to where I am. Okay. Yeah.
Mine is saying that it doesn't know what matplotlib is.
Okay. So if you don't have matplotlib installed, that's possible. Is that a lot of you guys getting that error? Okay. So that means we just haven't installed it yet. So I forgot to do that. So let's go. If we want to just open a terminal inside our current environment, remember it's important that if we install something, it's installed inside this conda environment that we're working in, which is the Python 3 environment. We're going to go back to the Jupyter, and we can say new terminal. So this will open up a new terminal in the current environment. If we want to check that, we can do conda env list, and it's going to print out all the con environments. I have a lot, but you can see that the Python 3 has a star next to it. So that means we're in the Python 3 environment, which is what we want. So now we can do conda install matplotlib and hit enter. I'm going to not execute that because I've already installed it. So that will guide you through. Once it says, do you want to install, hit yes. So this is the general thing you can do if you don't have a package that you need. You can just go to the terminal and install it, do a conda install. And you don't even have to restart your notebook. You can just go back to the notebook and run it again, run that command again, and it'll work. Yeah. So if you go back, once you do that and you go back to the notebook, you should be able to do these imports. Pylab is part of matplotlib. Okay. So Pylab is this MATLAB-like API. I don't typically use it, but it is available to you. So you can say here we have just an x and a y, two vectors here, two NumPy arrays. We can do first we can create the figure, then we can use this plot function to plot x versus y. And if you've used MATLAB before, you'll recognize this syntax. And then so it generates a line here for you with the labels x and y and title. If you wanted to do a subplot like in MATLAB, you can use the subplot function, and it works like this. So yeah, if you just, let's say you really want to do something quickly and you're more familiar with MATLAB, you might use this, or you want to convince a friend to start using Python who likes MATLAB, you can say, hey, you can use all your same plotting functions in Python. However, I don't encourage you to use this. I encourage you to use the full-on matplotlib pyplot, the matplotlib pyplot imported like this. So this is the command we want to use, and that to import the package, and then this gives us the full breadth of matplotlib functionality. So one way we can do this is we can first create a figure, and then we can add axes to that figure with certain dimensions. And then on those axes we can plot x and y and set the labels. So this is doing the same thing we just did before. There's a little more text we have to write. However, we have a lot more control over the figure and how it's rendered in many ways that we're not even seeing yet. So for example, we can do an inset where we specify a figure and then we add axes, main axes and then inset axes, and then to each of those axes then can be the object to which we plot something. So this is how one of the ways that Matplotlib works is if you define axes, those axes can then be plotted to as. So you'll see in a few minutes that there's different ways to create the plots, but this allows us to, for example, inset one plot inside the other. So again, it's giving us a lot more control.
What are the axes doing? Like those numbers, 0.1.
Mm-hmm.
What does that mean?
So these are the it's a list of 4 numbers, and they range from 0 to 1, which refers to the start to the end of the figure. So if the figure goes from 0 here to 1, this is not in relation to these units. It's just the coordinates of the figure. Then this list says, okay, I'm going to start at x, y. So this is lower. These are the coordinates of the lower left, and then this is the width and the height. So it's going to start at. So if you can kind of see the figure is sort of outlined. You can't see the outline of the figure, but so this would be starting at point 1 and going to starting at point 1.1 and then going to point 1 plus point 8, which would be point 9, and point 1 plus point 8, which would be point 9.
So it's like white space.
Yeah,
around?
yeah.
Okay.
But
Never used that.
But this is not how you don't typically need to use this command. This is just an example. You'll see a lot more ways that you don't have to specify those axes. Yeah, this is a part of the tutorial that I have kept in, but I'm not sure it's that relevant. So another one that we like to use is called subplots. So this will generate a figure and an axes object, and so you save them both when you create the subplots. The figure is the whole figure. So when you save as a PDF or something, that's something you're doing on the figure. But the axes are what you plot to, because you can have multiple axes per figure. In this case, we just have one axis, so it's that we then plot to that, and then set the title. The cool thing about subplots is you can pass. It makes a very easy way to generate multiple subplots. But importantly, you can, like we did here, you don't have to have multiple subplots to use the subplots command. It's a nice way to just set up your figure when you create a figure. But in this case, we do have multiple subplots, and we're going to have one row, 2 columns. So this axes object is actually going to be an array. We'll see that in a second, of 2 axes objects. So then we can use indexing to plot to those. So we can say axes bracket 0 or axes bracket 1, and we can plot and set labels to those different axes. I'm going to put a. Sometimes you'll get some. So this last command returned this text here. So if we want to suppress that output in the notebook, we can put a semicolon there. It's just for aesthetics. It doesn't change anything that's happening. But in the notebook, the only thing that you see is the output of the last command you entered. So if we want to suppress that, we can put a semicolon there. So what we can see is that axes is actually an array, and it has length 2. That's why we could use position 0 and position 1. And each of those elements in that array is a Matplotlib axes subplot object. So the next part here is showing that this looks good, but you can see we have this like overlapping axis label. So there's a nice function or method for figures, or for the figure object, called tight layout. And so if we run this same command, we can see that we can get better spacing. Another thing I've done is I've just turned the creation of these plots into a loop. You would probably want to change what goes into this loop when you create it, but you can loop over this array because it's an iterable object. Any questions so far? You guys have had some good questions already, so okay.